Lesson 15 project. So first we need to talk about vertical asymptotes, what they are, how you find them. So a vertical asymptote for a rational function where we have f of x equals p of x over q of x, where p of x and q of x are both polynomials that don't share any common factors. There's a vertical asymptote at x equals a for every value of a such that q of a equals 0. So we need to know that about vertical asymptotes. That's how we're going to find our vertical asymptotes. Then for horizontal asymptotes, for a rational function f of x equals p of x divided by q of x, where p of x and q of x are polynomials, and n equals the degree of p and m equals the degree of q, if n is less than m, meaning the degree on our top is less than the degree on our bottom, there is a horizontal asymptote at y equals 0. If n equals m, so if our degrees on the top and bottom are the same, then there is a horizontal asymptote at y equals a sub n divided by b sub n, where a of n and bm are the leading coefficients of p of x and q of x. So that could be any number, whatever number is in front of that highest degree in terms of p of x and q of x. So it might be like a 1 over 1, or it might be a negative 5 over 2, whatever the leading coefficients are. And then if n is greater than m, so if our degree on the top is greater than the degree on the bottom, then we have no horizontal asymptote. Okay, so we're going to use these about horizontal and vertical asymptotes in order to solve and get our vertical and horizontal asymptotes. So in the project for lesson 11, you found the quotients and remainders for two division problems. The result of division in each case involves the remainder written as a fraction over the divisor. Use r1 of x and a of x equals x plus 6. The graph of r1 of x divided by a of x has a vertical asymptote. What is the equation of the vertical asymptote? So first you'll need to go back to lesson 11 and look up what you had for your remainder so that you can use it. So if I go back to my lesson 11 and I look up my remainder, I had my r of 1 of x was a 9 for me. So when I put that into this equation here of r1 of x over a of x, I have 9 over x plus 6. So I know that this has a vertical asymptote because it tells me that it has a vertical asymptote. But now I need the equation. So in order to get the equation, I'm going to take my denominator and set it equal to 0. So I'm going to take my denominator of x plus 6 equal to 0. I'm going to solve for x. So I'm going to subtract 6 from both sides. So I now have x equals 0 minus 6 gives me a negative 6. So this is my vertical asymptote equation. So x equals negative 6 is my vertical asymptote. Okay. Use r2 of x and b of x equals x plus 3. The graph of r2 of x over b of x has a vertical asymptote. What is the equation of the vertical asymptote? So again, I need to go back and find my r2 of x and plug it into my equation. So my r2 of x was negative 19 over my b of x, which is x plus 3. So I need to now find my vertical asymptote. So same thing, take the denominator, which is x plus 3, set it equal to 0, and then solve. So I'm going to subtract 3 from both sides. So I end up with x equals negative 3. So x equals negative 3 is my vertical asymptote. And that's what it's asking me for. The graphs of r1 of x divided by a of x and r2 of x divided by b of x have the same horizontal asymptote. What is the equation of the horizontal asymptote? So I want to know the equation of the horizontal asymptote, and it's the same for both of them. So I'm going to first write out my r1 of x over a of x and my r2 of x over b of x. So I had r1 of x was 9, a of x, x plus 6. My r2 of x was negative 19, and my b of x was x plus 3. So then if you remember back to the horizontal asymptotes, there were 3 different ones. So we needed to figure out, is our degree on the top higher, lower, or the same as the degree on the bottom? For both of these equations, it's the same. So they both have a constant on top. So that means our degree on the top here, since they both have a constant, our degree on the top is going to be 0. Our degree on the bottom, for both of them, it's the same. They both have an x, so that means our degree is 1. So our degree on the bottom is greater than our degree on the top. So when that happens, from the 3, when our degree on the bottom is greater than our degree on the top, that means our horizontal asymptote is y equals 0. So that is our horizontal asymptote, y equals 0, since our degree on top is less than our degree on the bottom. Why do both graphs have the same asymptote? Well, that's what we just went over. Because the degree of the numerator, so because our degree of the numerator, remember the numerator is the top of a fraction, so because the degree of the numerator was less than our degree of our denominator, which is the bottom of a fraction, remember, that is why they both have the same, because they both have that the degree of the numerator is greater than the degree of the denominator, is less than the degree of the denominator. So since they both have the same thing, that is why they both have the same horizontal asymptote. Now, if they would have been different, if one of them would have had the degree like it is, where the degree of the numerator is less than the degree of the denominator, and the other one had it to where the degree of the numerator was greater than the degree of the denominator, then we would have different horizontal asymptotes. But since they both have the same situation of the degree of the numerator being less than the degree of our denominator, that means that they both have that same horizontal asymptote of y equals 0. Okay? So that is your project help for lesson 15. If you need any help or have any more questions, feel free to contact me.